So for this problem, we're talking about the difference between two proportions. And we're testing the claim that the proportion of men who own cats is smaller than the proportion of women who own cats. So they want us to pick the null hypothesis. Well, remember, HO is always a statement of no difference, and since we're dealing with proportions, we don't want to be dealing with means. We want to be dealing with here. Let me get a pointer going here. Yep. We don't want to be dealing with means, so we don't want the mu symbols. We want the p symbols. And notice how they use a nice little subscript for male versus female. So we're trying to say that the proportion of men that own cats is smaller than the proportion of women who own cats. So that's the claim. And the way I'm reading this, I think the claim would be H1. So this says the proportion of men is greater than the proportion of women. So that's not what it's trying to say. And then this is the proportion of men is less than the proportion of women, and HO is equal to, so that is going to be the right answer. So since we're dealing with a less than, this is going to be a left-tailed test. And then we're going to run the test statistic. So if I go to Rossman chance, I got to select two proportions. I've got, let's see, I've got 60 men total. And then I got to find what 35% of 60 is. So I'm going to grab a calculator off screen here, 0.35 times 60, and I got a nice whole number of 21. If you're doing this and you don't get a whole number, you have to do some rounding. And usually you follow rounding rules, and usually it's close enough. And then the next one is 50% of women, 50% of 20 women. Well, I don't even need a calculator for that because that's going to be 10. And then we're going to do a test of significance. And we did a left-tailed test, and we're saying the mean difference. So remember, in this version, they brought the P1 over. That's so they subtracted the proportion of females from both sides. You did a little algebra. And it's a left-tailed test. Now I'm going to calculate. So there's my test statistic. There's my p-value. Let's see what my graphing calculator tells me. So I'm going to quit this. Let's see, quit, let me clear. So then I'm going to do stat test, and I want a two proportion z test. You see choice 6? And then asking the same information. And of course, I already did this calculation. So males is 21 out of 60. And females are 10 out of 20. And I'm choosing a left-tailed test. And I'm going to calculate. And am I getting the same values? I am. The p-value is even the same. So I think we'll be pretty good with going with these answers. Now, one thing with this problem not asking us to do is to check the conditions. Let's see. So what's the test statistic? Let me do one thing before I forget. There's the test statistic, and there's the p-value. And because that's such a large p-value, I'm going to fail to reject the null hypothesis. And I'm pretty sure this will give me right answers. Did it? Did I get everything right? A whole bunch of greens. That's good. Okay, so hopefully that'll help you solve this question.